Well, we're here at SSI Innovations. I'm visiting with Dr. Vishwa Srivastava. He is President and COO. Thanks for giving us a tour of Mantra. There's been a lot of buzz about it, and I think a lot of anticipation prior to the show. Tell us a little bit about its history first. I mean, you folks came together with it pretty quickly. As it was
so we started the journey back in 2014. Our chairman, Dr. Srivastava, same last name, same relationship. He's my father. He was one of the early pioneers in robotic cardiac surgery. And, seeing sort of the pitfalls or unavailability of access to this wonderful technology that we call surgical robotics, he undertook the mission to develop affordable systems so that the rest of the world could really benefit from these types of technologies and surgical approaches. They started in 2014, initially just first learning the core fundamental concept of surgical robotics and robotics in general.
Mm-hmm.
Then our Mantra 1 system we completed in 2020. We did a clinical trial, but we discovered very quickly that it wasn't going to work for the average surgical team. And, of course, you can give your any system to like all-star surgeons. They'll figure out how to make it work. But it was very different than this system. So during the pandemic, we went back to the drawing board. Within 6 months, we had developed our second generation, Mantra 2, which the majority of now are placed within India. And we've done till date, I think, more than 1,400 cases, 70 different types of surgical procedures.
70? 70?
Yeah, 70. So
wow.
From transoral all the way to the pelvis and everything in between, including cardiac surgery. So that's one of our key areas that we're really focusing on. I think a lot of it had to do with the, really focusing on cardiac surgery. We really want to revive the field because, as you know, the original robot was developed for cardiac surgery.
Aim for the heart.
Aim for the heart, but land on the prostate. Right? And, because it's such a wonderful technology. See, with all due respect to other specialties, you still have endoscopic options, laparoscopy. Whereas in cardiac, 95 to 98% of procedures done today are still done through a median sternotomy. So it's highly invasive, long recovery periods, higher chance of infection, slower return to functional status. So we really wanted to take the early work that our chairman had done in the space of robotic cardiac surgery and, really integrate that into our system, from day one. So some unique things about our system. This is our third generation system. So we made this in about 5 months, started in January.
Why do you iterate so quickly? And I'm not trying to throw anyone under a very large bus, but a lot of companies are taking longer to put together system one.
I think it's two things. So one, in India, we have access to brilliant, young, charged up engineers who really devoted a lot of their time and effort and in a very disciplined approach to really taking what they've learned on from previous iterations and really, sharpening their skills and sharpening, the amount of work that it takes to refine and implement, new changes into a new system. Secondly, we're a very flat organization, so we don't have a lot of bureaucracy. And I have this saying is that as a company that's started by doctors, run by doctors, all the input we get are from our end users who are also doctors. And ultimately, we orchestrate our plan of action with our team of engineers who are also scientists. So we really want to remain a very, facile, science-based organization. And then we'll focus on the work, and the business part will come secondary if we do good work.
Obviously, no, this is cool. So talk a bit about the arms and the design of this part, and then we have to talk about the chair.
Sure. So we wanted to go with like a very modular approach. We felt that we wanted to do something original. We didn't want to copy. Yeah. That was very important for us. And so this iteration of arms, so they have to be very stable. If you make the arms too light, you see all the motors at every joint level, they're very powerful. And with all motors, there has to be some vibration, right? Because you have moving parts. So that vibration can be carried in one of two directions. Either it'll go to the tip of the instrument, which is the last thing that you want in surgery, or it can be transferred to the base. So the base is very sturdy. Each part weighs approximately 280 to 300 kilograms. So it's very stable once it's docked. And additionally, our newer generation of arms are much slimmer than the previous generation. Of course, these actuators, they work on, they're motor driven, and they have sort of these discs at the end of each instrument that gives you the 4 degrees of freedom. So that combined with the X, Y, and Z motion of the arms, that gives you a total of 7 degrees of freedom. We wanted to be able to do, all the general surgical procedures in abdomen and pelvis, but we really wanted to be able to keep, because the one thing that's most important with any robotic system that you see is that all of this stuff ultimately it leads to support what's happening at the tip of the instrument.
Good point.
And so it doesn't really matter, everyone, like there are many rivers lead to the same ocean, you could say, and for us, we really like this because now due to the modularity, we can position our arms anywhere. So it allows us to be very creative in our surgical approach where we can now think about it totally differently. So the three things that we always have to consider, what is the target anatomy? What is the trajectory of the instruments that you want? And also the size of the patient, so patient body habitus. So all those three data points are very critical in surgical planning. And it's allowed us a lot of room for thought and room for improvement in how we look about setting up and docking the robot prior to surgery. Until date now, we've done more than 70 different types of surgical procedures, including cardiac surgery.
Wow. So what are the benefits in cardiac surgery, and why the previous companies missed the heart and hit the whatever? I mean, what is the challenge of cardiac surgery, and how did you overcome it?
I think cardiac, being, so one, you have a very small workspace, so it doesn't expand like it does in the abdomen.
Sure.
Like when you pump with CO2, most of the times you have to do, single lung ventilation. You have to take down a lung in order to create space. In addition to that, it's very high risk. It's one of the few specialties where you can kill a patient on the table immediately, and due to that, the learning curve is quite exaggerated. It takes a lot longer, to get to what you're doing in an open scenario. And thirdly, I think that the instrumentation, so enabling instrumentation, it's no longer available, so we had to revive that. So for instance, in cardiac, this is our cardiac stabilizer, which allows us to do beating heart, totally endoscopic bypass surgery. So while the heart is beating, you just put it on the area we're going to do the bypass, creates a stable working space where then you can do the anastomosis. Another cool thing we've developed is our anastomotic connector. So it's a micro-stapling device that basically you can do an end-to-side anastomosis in 6 seconds. And then once you take it out, then you have to just do a closing stitch. So what this is actually really revolutionary. We have two versions. One is the robotic version, and then one is a manual version. And this will really revolutionize the way bypass surgery is done, because now what you're doing is you're taking away long anastomotic times, variations of skill level between surgeons in hand sewing, and this would be a really a good way that to perform bypass moving forward, so that you can save on time, less anesthesia. If they're off pump, on pump, you can get the job done. Now these devices will have to undergo a clinical trial due to the class of the device, and we feel that doing them in India, we can knock out the 100 cases very quickly. Then of course we'll have to do post-op angio to check for graft patency, probably 6 months post-operatively.
How does it get? I don't understand. It's not rigid like the rest. What am I looking at? And how is
so this is for the open approach. So let's say you don't have a robotic system.
Oh, I'm sorry.
Yeah.
Okay, great.
Yeah. So then, but we do have it as part of our robotic armamentarium. Then with regards to cardiac, we have these atrial retractors. So the smaller one, of course, would be for the right atrium, larger one for the left atrium.
Okay.
So when you're doing intracardiac procedures, so we really wanted to, provide everything that was needed so that cardiac surgeons, we could, give them the enabling technology, what they need to be able to revive the field. In addition to that, we have all other instruments for all of the specialties. One unique thing about our system is, I don't know if you can see behind me here, on our vision cart, right from day one, we wanted to give 3D vision to the entire team. I think it's safer. It's from a teaching training point of view, orchestration with the tableside team. I've seen so many lab cases where surgeons are trying to, or their assistants are trying to clip vessels, and they're missing it because they don't have any depth perception. Part of the reason why we wanted to integrate 3D from day one was Dr. Sudhir, my father, was training a team in Korea, back in his Da Vinci days, and he saw a quick flash of light, and then all of a sudden this blood starts pouring out of the left ventricle. So he fixed it, obviously, in the case, and then after the case, he asked the nurse, he said, "What happened?" She said, I just couldn't tell how deep I was going, because the way that I look at it is like, God has given us two eyes because that gives us 3D vision.
Yep.
So when you're looking at something in 2D, it's like operating with one eye covered, and now you're only seeing in 2D, right? So we thought that, there should be no reason why, especially with the available technologies today. 3D monitors are available. We're using a 3D scope.
Are these the glasses that?
Yeah, these are the glasses you use to see in 3D.
Oh yeah, wow. Okay.
Yeah. So, we really wanted to, level the playing field so that the tableside team has the same view as the surgeon, and that'll, keep everybody on an even keel. So we wanted to make, this is our third generation. It's pretty disruptive in my opinion because we've taken away a lot of the hardware. There's no gimbal, so that you don't have these fixed hand controls like you do traditionally. We're using these magnetic hand controls, and there's at the base, so there's it establishes a magnetic field. So you have the source of the magnetic field, which establishes like a 2.5-foot radius in like a virtual boundary, so that how you move your hand controls, so it correlates to that. So if you're already a robotic surgeon, you already have the muscle memory. You know, it'll be very ergonomic and very easy to use. I've also trained surgeons with zero robot experience on this platform, and for them it took a little bit longer, but then they enjoyed it because it's they're less than 100 grams.
Oh yeah.
And they're accurate to 0.1 millimeters. System latency of these hand controls is about 3 milliseconds, so it's nothing. And we've used these same types of hand controls for our telesurgery experiments. On the bottom, you have the foot tray, which all the standard foot pedals, master clutch, camera pedal, and then cut cautery and coagulation. And then we got rid of the monitors. Now we can still give you a monitor, but we're using this mixed reality headset, which gives you a beautiful, it's almost like 42-inch 3D view of what you're operating on. And should you not want this, then you can easily put a monitor in front and then just use the 3D glasses. So we want it to be pretty flexible, giving the surgeons what they want.
How much discussion was there in it being a chair? I mean, it's unlike any other sort of position that a surgeon would be in. I could see them almost saying, "No, I need to be in game position," and this is more of a
So we wanted to. I call this the Professor X chair, like the X-Men. But see, in long surgeries, especially like ergonomics, the surgeon should be comfortable.
Yeah,
I mean, as we all know, like in the evolution of surgery, open surgery, which is a maximally invasive approach, it's horrible for the patient, but it's great for the surgeon. Why? Because they can see everything. Then we had the transition to laparoscopy, where now it's good for the patient, but now it's not. It's pretty challenging for the surgeon because you have to be in a lot of awkward positions, and now you've transferred those limitations onto yourself. Suturing became difficult, and it just wasn't the same as the open approach. When robotics is good for the patient, great for the surgeon, because now you have wristed motions, you have magnified vision. But the problem was, the ergonomics. Like, was there always could there been room for improvement? Of course. So we felt that sitting straight, this is a gaming chair, so it's super comfortable.
I wondered if it was.
Yeah. And we have all these nice pads, memory foam, everything.
Can I get in?
Yeah. Hop on in.
Yeah, very comfortable.
Yeah, and this is actually this is our prototype. Our official chair is like on the way. Unfortunately, got stuck in customs.
Oh, okay.
Yeah, they were wondering what this.
Be too careful with the chair.
Professor X's chair. How did it get here? But so far from SRS, we've had a lot of good feedback. I think people like this disruptive approach that we've taken, and we'll see. You don't know until the tires hit the road.
Yep.
But I think that we're really looking forward to doing more clinical cases on this platform.
Well, it's impressive bit of innovation, not only the speed but the features, and can't wait to see what Mantra 4.
Yeah. You have to give us a break. We just finished the third one.
We'll give you 6 months.
Yeah.
Thanks so much.
Thanks, Tom.